I figured it's late in the afternoon and we need something to wake us up a little bit. And that's one of my favorite movies. But there were actually two other reasons why I added this clip at 7 a.m. this morning. One was it horrified my marketing manager, and that always makes me happy. The second is because there's a very powerful message in this classic movie clip, which is, it isn't good enough to just detect. You have to acquire a target, and you have to be able to act on a target. In this case, it's about dinner for a dinosaur. In our past at AEye, our heritage is building ISR systems, automated targeting systems, and missile defense systems. So we have something very much in common with the fact that they used a laser or a LiDAR in this clip, which is when you can't afford to miss anything entering your scene, you have to determine which objects are more important than others, and you have to do it very quickly. You're going to use a combination of sensors. In the case of our company, we use a camera, a LiDAR system, and have trigger senses like radars. The reason that that's important is because a year and a half ago when we came onto the market, everything in the world was about LiDAR and how LiDAR was superior and how LiDAR would save the autonomous car industry. Having spent the last 25 years building different types of systems, it was clear that we had to actually come in and do something different. And as my father said, how you define the problem actually has a big impact on where you see solutions. So what we set out to do, starting in 2013, but 2 years ago accelerating these efforts, was to actually ask ourselves a different question. Obviously, autonomous cars need sensors. They need sensors to perceive the environment. But what we set out to do was build a perception system, not a sensor system. And in fact, we decided to build a perception system that could out-perceive a human eye. So many of you may know that in neuroscience, biomimicry is a very, very hot concept. It flies in the face of a lot of where I live in Silicon Valley because Moore's Law is as much of a religion as human psychology and biomimicry. But when you combine the two, you can do amazing things. So the human visual cortex is not the human brain. It actually processes 75% of what you see in the world on the edge of the network. Over 40% of your vision is actually determined by senses like smell and touch and hearing. When you hear a siren, you foveate to the left. When you smell an apple pie, you look for something round. These senses have been actually built up over hundreds and hundreds of years so that we can actually intelligently perceive. Because as you're collecting information about the environment, if you intelligently perceive, you use less power and you take less time. And in ancient history, that was the difference between life and death. There was a great line in the clip that said, hey, we're taking something from the past and we're adding technology to really drive innovation. We're taking the human visual cortex, which has been the basis of human consciousness. We're actually biomimicking it, and we're adding in a lot of technology that was based off of these automated targeting systems and military systems to actually give you something that not only replicates what a human does, but as we say, allows it to think like a robot and to actually perceive like a human. That's important because depending on which study you've read, 70 to 90% of all accidents are caused by human distraction. So humans are actually extremely good at perceiving at distance and at speed by multiple different methods. Where they fall down is we eat and we drink and we get tired. So one of the things we set out to do is to actually build a system that would take the best of a human and actually marry it with the best of a computer. So I'm going to show you the first video. This is just a LiDAR system. Many of you have seen point clouds before. What that LiDAR system is doing, though, is something very, very different. Almost every LiDAR system in the world, other than very, very expensive military systems, only detect objects. So again, it can detect it. This system is actually acquiring those objects, deciding what they are, and then resolving those objects. This is important because if you think about biomimicry, you don't actually wait when you touch a hot stove to pull your hand back. And you don't actually duck when a baseball is coming at you because, again, you're processing that information and deciding the intent of the object very early on. In fact, there's a lot of science that goes around how humans actually interrogate. In fact, when we see an object entering our field of view, we look for the sides of it, and we actually look for the size, vector, and velocity to decide whether it's going to be a danger or not. If you actually take the concept of human biomimicry and combine it with what we've done for billions and billions of dollars in automated targeting, what we're doing is actually, instead of finding things to kill, we're finding out how not to kill things. And in doing that, we're creating a system that can be deployed in automobiles much, much sooner than, say, a system that collects a tremendous amount of data. One last fact, what you see today in detection systems, today they bring in data. Many of you may not know, but they only bring in data one way, and they bring it in passively. So they spend as much effort on the sky or the leaves of the tree as the girl running across the street, because they're unable to actually foveate and to focus, as this system does, on objects that matter in the scene. So if we go to the next screen, what I'm going to show you is that we actually have both a camera and a LiDAR system. Now again, this may seem like a simple graphic to you. That's never been done before. We're acquiring color and depth at the exact same time. That's as close as you're going to get to a human's capability to process in 2D and 3D. We're not fusing it in the trunk of the car. We're not fusing it seconds after we've taken both those pictures, and we're not having to actually use parallax to figure out whether we're looking at the same thing. We're actually acquiring orthogonal information at the point of acquisition. So not only can we acquire objects in general, we can acquire objects with color. So by actually taking a step back to the future and looking at how we comprehend things, we've actually been able to teach a computer how to comprehend things better than a human does. So why don't we go to the next one, Steve? So I separated these two streams back out. This is Chinatown. Some of you may recognize it. And what we're doing here is actually, again, using the Agile LiDAR and the camera to go acquire objects. So why don't we go to the next screen? You can see the people in that screen were actually in high density, and now we're actually tracking. We're doing object detection. So first we foveated and found the objects that were moving that we cared about, put extra effort on them, and now we're actually detecting them. Again, go to the next slide, please, Steve. Now, at this point, we're doing what you do naturally, classifying those objects, because it's not good enough to know that they're there, right? It's not good enough to actually know that there's discrete objects. What you have to do is figure out what that object is if you're ever going to get to the intent of that object, right? So why don't we go to the next one? I wanted to stop there because while I wouldn't have noticed it the first time, and none of you would have noticed it the first time, if you take a look at the LiDAR scan, you will see that the camera didn't pick up that human. So there's a pedestrian in the middle of the street in low light where there's a degradation of light where the camera was fooled, back to some of the accidents that you've seen in the last couple of years. Ironically, if you take a look at the sign up there in the green, you can see the sign with the camera, but you can't see it with the LiDAR system. So one of our points around evolutionary biomimicry is to not have confirmation bias. So while we have spent the last 2 to 3 years around building better and better sensors, just like we moved from hardware to software to system integration in computers, we're now about to enter a completely new stage of perception, which means we're moving from making things work over and over again to combining things where it's not a choice between is a camera better than a LiDAR system or a LiDAR better than a camera, or if I have a radar system, can I add this in here? It's can you combine the two so we don't miss anything? And this is what's been missing. So when you ask yourself why cars can only drive 25 miles an hour in highly geo-mapped areas, it's because they're not using all of their senses. So, see, why don't we go to the... So once we actually figure out what those objects are and we actually start to track them, just like you would for people you know or people you don't know, we move them through time and space. Then we start to ask ourselves some really interesting questions that you do subconsciously. What's the velocity of the object? Is it accelerating or decelerating? While we may be able to estimate that, is a car going to run that red light? A camera and a LiDAR system can tell me whether that car is going to run a red light. Then we can move in to the next phase, which is motion forecasting. This is really the secret, and this really changes everything. The difference in what I'm showing you today and why we have a press conference today is because while this is very well known, and many computer scientists will walk through these exact same steps, no one has ever been able to do it inside of the sensor or the visual cortex at the edge of the network. With this capability, you now give the OEMs, the tier ones, the technology companies, the tools that they need to mix and match heterogeneous nodes, all in software definability, so that they can actually decide where the decision is made. Is the decision made in the sensor? Is it made in the trunk? Or is it made in the cloud? Because this is really about data being turned into information. So while there has been a great deal of consternation around how quickly, the first question I get at any cocktail party is, did you lose weight? Because I have. The second question I usually get is mobility really going to happen? And is it going to happen before 2030? And the answer to the question is, we're now beginning to take advantage of all the work that's been done to try to get robotaxis to work, and now it's being pushed back onto a continuous spectrum. So everything from ADAS systems, which every commercial on TV you'll see, a sensor is going to be embedded in a car, to autonomy on demand, where you may only use it on the highway, you may use it only in the city, you may use it only for parking, or assisted autonomy or full-time autonomy. So what I hope that I've been able to convince you today is that the death of autonomous cars has been greatly exaggerated. Autonomous technology, which has been developed over the last 3 or 4 years, while level 5 cars may be a few years away, you will start to see this technology embedded in everything that moves out there, whether it's a scooter, or it's a car, or whether it's a public bus. So I think that's the end of our presentation. Steve, do we have one more? So if anyone would like to actually see how this works, we have a car outside. We also have a set of case studies that you're welcome to see on our website. And I will tell you that I'll make the prediction that I think there have been 3 waves. The first wave I didn't understand because I was young and I thought I was just so smart that I was making my company go public and the internet, is that the internet brought communication costs down to 0. A lot of businesses exist because of that. Smartphones brought compute power costs down to 0. A lot of businesses exist because of that. While we're talking about logistics and we're talking about autonomous vehicles, in the end of the day, if we get logistics to be less than $1, logistics is free. A lot of businesses don't exist today will be able to exist for tomorrow. So I actually believe we're in a 3rd wave, and it's very inspiring today to listen to all the different ways that autonomy is being applied. And thank you very much for listening to us today.